Dear DevOps engineers, what if I told you that in your organization, developers can merge production code without approval? You'd probably react like, like if you lost your mind. But then I proceed to tell you that DevOps engineers and admins are able to delete cloud resources without approval. I'm not saying they're doing that. I'm saying they can do that without approval. And then you probably say, oh, those admins, they know what they're doing, right? And this sort of a double standard causes a fact with made-up numbers that there's a lot more cloud oopsies than code oopsies. And it stems from misconfiguration, human error, and threat actors. Hi, my name is Yoav Yanilov. I've been a software engineer for about 13 years, doing backend and then doing DevOps work. And I want to share with you my journey into cloud approval systems. It's kind of a funny journey where I got all the specs wrong and ended up working and making a novel approach to cloud approvals. I hope that by the end of these 20-something minutes, you'll have like more information about cloud approvals and the risks they mitigate, knowledge on novel approaches to attribute-based access control, ABAC, and maybe some insights on how you can integrate something like this in your AWS organization. On brand with the spooky theme, the agenda for today is doom, gloom, and despair. But by the end of the talk, I want you to think of them as rainbows, sunshine, and unicorn poop. And in between, we'll just call them by their name. My SOC 2 journey, cloud approvals, and control tax, the proposed solution. When I was working at SimilarWeb, we were approaching the first SOC 2 journey, SOC 2 certification. It's a security certification. And like right off the bat, I'm looking at the SOC 2 manifest, and this pops up. Changes to infrastructure need to be approved. And I'm not a security engineer by any caliber. It caught me off guard because I didn't know how to do that. What I didn't know is that AWS and everyone else says that there's a thing called break class access, right? And yada, yada, yada. It says that there's a restricted, very small group of people that can do something like that. And that's admins, right? The rules don't apply to admins. So it is kind of a double standard. And that kind of led me on a journey, right? I got the specs wrong. I didn't know that there's a thing called break glass protocol. Name of the journey is Cloud Native Approvals. And to reiterate, cloud approvals is easy. GitHub has that since 2016. And since then, they've added more features and more features and more features around that little green approve button, which is great, by the way. However, the state of cloud approvals is not good. The best thing we have, the closest thing we have, something like RDS, is deletion protection. It's just a little toggle that you can turn on and off to prevent you from accidentally deleting the database, but there's no sense, no notion of approval. It's part of it. There's not a second human. And if we had a candid talk about deleting a database, a cloud database, it'd probably go like me asking you, hey, who can delete database in your organization? And you'd say, no one. And then I'll inquire further. And then you'd say, well, there's the CI role, but that's guarded behind the green approve button, right? It's approval. And then I'd ask, how are you protecting that role's credentials, may they be temporary or not, against like a compromised admin? It happens. And then the worst thing that can happen does, your chief security, information security officer joins the chat. And there goes your weekend. Things that desperately need approval are nuclear missile silos, cloud databases, and conference speakers. And you may be asking yourselves, like, why even solve this thing? Is it even important? Google seems to think so. Like, starting 2024, as an admin for Google Workspace, you're not allowed to execute sensitive actions like turn off multi-factor authentication without a second admin's approval, right? So Google seems to think so. But when we started as SOC 2 workloads, the year wasn't 2024 and it wasn't G-Cloud. It was 2019 and AWS. And even now, in 2024, AWS still doesn't have a good enough story for cloud approvals. Thinking about how to implement something like this started with me staring at a wall for 2 weeks straight while the rest of the security task force is laughing, saying, you're never going to get it. And then like something switched, and the journey towards cloud approvals can be comprised of 4 levels. First, we need to look into modern authorization and realize that it's sort of broken. Then we will attempt to fix some of it, which will pave the way to approvals, and then enable us to even extend approvals to other systems like Kubernetes. And before we go any further, this is sort of a technical talk. It assumes that you have a lot of knowledge with IAM, but we'll do our best to fill in the gaps where needed. First things first is becoming an expert in IAM. Makes sense. And if you want to like enforce permissions at scale, the first thing you have to look at is SCPs, service control policies. So it's just an IAM policy, but you attach it to an account, and it applies automatically to each and every IAM role and user and whatnot in that account. Now, I mentioned ABAC, attribute-based access control, before, but let's talk about it and let's see how it compares to something like ABAC, role-based access control, which everyone's probably familiar with. So we had like an ABAC policy. So deny RDS delete unless if the principal ARN, the identity of the principal, is role admin, right? Only the admin role can delete databases, which makes perfect sense. It's very straightforward. While in ABAC, you might have something like delete RDS, deny, unless there is a tag, like an attribute, on the calling principal. The name of the tag is admin, and the value is true. So it's a key value thing, tags, attributes. And the problem with ABAC role-based access control is that it fails at scale, right? Get up in the morning, there's a new security requirement. It says that deny RDS deletion unless, and then you see this. You wanna die, because it is admin, and it's not a production database, or it is a production database, and the admin is also on call. This is not something that I want to spend my time as a security engineer working on. It's not a problem I want to solve. It's tedious, it's hard. It's not a good hard, it's the bad hard. ABAC, attribute-based access control, however, scales really, really well. This is more or less the policy that you have to make, and then you just have to inject those attributes at the certain time, and the entire system computes it at real time. In AWS, attributes are tags, and tags can be found all over the place. On principals, which is the generic term for IAM user or role. On the resource, there can be tags, and if the request itself has tags inside it, like add tags to a resource, there's also tags in there. And there's also a possibility to inspect all of the keys of the tags, even if it's an untagging request. So by now you're probably saying, hey, just use attribute-based access control. What could go wrong? Well, it turns out there's this thing called privilege escalation, which means that a principal may be able to make lateral movements and gain more permissions than what it started with. In this example, you get a dev role that's able to pass along a role to a Lambda function and then write code for that Lambda function that is able to delete the RDS cluster. I think this is like reason enough to believe that modern authorization with attribute-based access control is kind of broken. It's broken because you have to take care of privilege escalation all the time. And if you attempt to fix something like this, you'll have what we call an integrity logic, sort of like a closed club. You see that in many IDPs, like you have to be an admin in order to make someone else an admin. So in this case, you have to have this tag, is admin true, in order to tag someone else as an admin. Perfect sense, right? But does this scale, right? There's not one SCP. There's many policies, all of which apply to whole accounts. And you're telling me that I have to write this very error-prone thing about integrity as like in addition to the access control logic? Ideally, I'd have like more stable separation of concerns where I'm able to write just the access control logic and have a centralized integrity control logic. Before we get to a solution, we'll ask ourselves, well, it's a problem. How's everyone else in the industry doing it? One word, money. It's called approval security. There's an IAM service called Access Analyzer. It leverages SAT solvers and a technology called Zelkova. And it's basically reactive security. It's a cluster of machines that tries periodically to prove or disprove. Sorry. Who? Tries to prove or disprove that there's a way for a principal to gain additional permissions. And it's great. It's a great solution, but it's reactive in its sense, and it has a cost. It takes time, takes money. What if you want to have something that's preventive, something that has no cost? How can you scale this mountain that's called integrity of tagging and attribute-based access control? Well, let's try a path-based approach, like Unix paths. Let's say that there's a grants file, and it's read-only, and it contains the paths of every user in the system. So Alice has a grant path of /home/Alice, so she can read everything under home Alice, like Git and memes, but she cannot access Bob's folder or system folders. Makes a lot of sense. Without further ado, introducing control tags. Control tags is a scalable integrity framework for AWS with ABAC. And we start off with a very arbitrary definition, saying that control tags are tags whose keys start with the prefix tag_ctl:. Okay. And this is the money shot. This is like the most important slide of the talk, for me at least. This is the gist of the control tags SCP. Remember, it's a policy that you attach to an account. You have two statements here. The first says, you got to have skin in the game in order to play the game, right? If you don't have a grant path, you're not able to tag any tag that is a control tag, which starts with the tag_ctl, whatever. And the second one says, if you're already tagging a control tag, that tag must be a nested path of your grant path, right? Just like Unix paths. Same thing expressed in IAM. And if we were to revise the delete RDS SCP we've seen earlier, which attaches to an account and affects each and every IAM user enrolled in that account, we'll only have a control tag saying that you got to have an admin RDS deleter equals true, which correlates to the grant path, the tree that you have permission to be either admin RDS or its parent, right? V1 admin or its parent V1. And if we were to make like a generic recipe for ABAC at scale, we'd have first connect the control tags SCP to an account, then connect our own SCP, which provides like data plane to the account, tag the correct principal, right, saying it's an RDS admin, and then, only then, that principal is able to elide the deny statements in that SCP and actually be able to delete the RDS cluster. So this is great. This kind of fixes modern authorization with ABAC by creating a hierarchy. However, it's not an approval yet. We have to pave the road to that. And our first use case here is to require that two admins collaborate in order to delete an RDS cluster. This is our first use case. And I want to show you a demo of how it works to get you on board. Let's have a look. All right, we're seeing two sessions. Left is Alice, right is Bob's. These are their identities. Now Alice tries to see that there's a bucket, delete me if you can. She tries to delete that bucket, and she gets an error, access denied, SCP. Next, Bob setting a ticket for Alice, approves Alice. Alice sees that she has a tag now, and when she proceeds to delete the bucket, she's able to do so. See here that the bucket no longer exists. All right, so what just happened here? First step, Bob tags Alice's role with something we call a 2PA ticket, two-person approval ticket. And second step is Alice, with that ticket assigned to her IAM role, is actually able to bypass the deny statements in the SCP and be able to delete the bucket. The anatomy of how to build something like that, remember it's a key value store tags. So the key is a control tag, and it starts with /admin, so it's an admin feature. And the value has three components: the giver, the receiver, and the payload. And both giver and receiver are correlated to source identities of the humans driving those roles, which is a sticky property of AWS. Just one set, you cannot change it, you cannot remove it. So it's perfect for that sense. And to reiterate, it's an admin-only feature. It has to be like anti-impersonate property, meaning your identity is immutable. It has to be anti-cheat, meaning that you cannot approve a ticket for yourself. Anti-forge, you cannot say that you're someone else, right? And it's also anti-stale, meaning that the approval has time to live, an expiration date. And before we dive into the implementation, I wanted to take like a long breath. First steps first, anti-impersonation. We have two statements here. First one says that there's a whitelisted, list of principals able to even assign identities like AWS SSO, maybe a credential broker, like a credential vendor inside your organization. And the other one says that in order to tag a 2PA tag, a two-person approval tag, you must have a human identity, which makes a lot of sense. The second part is anti-cheat, meaning that the receiver part of the tag must not be you. You can assign an approval to anyone else except your own identity. Third part is great for auditing, meaning that it's not part of the security standpoint, but it's great to look at CloudTrail events and see who actually gave the approval ticket. And that must be the same as your own source identity. And the fourth part, which is not IAM anymore, it's like a little system. It's a little Lambda function that wakes up every 30 minutes, scans the entire organization, and picks up and deletes every approval ticket that is invalid, right? Like maybe expired, no expiry date is too much into the future. And so that's about for the control plane for two-person approval. And data plane is very, very simple. It's very simple. It just says deny, delete, RDS, whatever, unless you have a 2PA ticket assigned to your own source identity. That's it. No integrity logic, only access control. So this is kind of a win. And the cherry on top that we can take that little statement and just plug it inside the control tag as SCP we've seen before, and say that two admins collaborating have the ability to tag outside their own grant path, meaning they can crown new admins, which is kind of the equivalent of by getting someone else's approval, you now have the option to edit the grants file. This solves essentially approvals, cloud-native approvals on AWS. And the road from here is doing the same thing, but not for actions, doing it for actions on resources. It's called 2PA seals, because we seal specific resources. And the workflow is like pretty straightforward. How did you expect it to be? There's an admin without an approval, and that admin cannot reveal sealed secret. However, an admin that has an approval is able to reveal the secret and is also able to manipulate the seal itself. So we'll skip over the policies for that one. But if we stop and reflect about 2PA seals, we see that they're like very useful. You can use them to hide and protect recovery keys, protect RDS clusters, like maybe production only. And the interesting thing here is that you can also use them against privilege escalation. This is what we affectionately call the 2PA relay pattern. Basically, it just locks in a role so that no one can assume that role without an approval, and no one can change that role's trust policy. And once we have this in place, we're able to extend approval to other systems whose IAM systems are not strong enough to express approvals, like Kubernetes. Our goal here is to prevent an admin from deleting Kubernetes deployments. And the way we do that is that we map our super user admin to something that has systems master's permissions. And we tag the same role, just how we've seen before, with a 2PA relay. And now you have to have an approval in order to assume that role. And once that role is assumed, this is the only way you can access the Kubernetes cluster and gain permissions to delete deployments. And this is, in a gist, how to extend approvals to Kubernetes. In summary, so started off like not knowing anything about SOC 2 and getting the specs all wrong, but it ended in us building like a very novel approach to scaling integrity for attribute-based access control and cloud approvals. It's running in production since 2019, and it's used for protecting sensitive actions, approvals, seals, 2PA relays, IP and VPC allow lists, cross-account isolation, and much, much more. And like the best thing is, it's now open source, so you can download it and play around with it in your organization, see if it fits. My name was Yoav Yanilov, so thank you very much. Any questions? Thank you.